hope I can modify this. Can't. We might have to zoom out a little bit like this. It's kind of unfortunate because I wanted to get a little bit better of a zoom, but it's not looking like it's going to give me that camera option to move. Focus back down here. Look at that. Oh yeah, there we go. I did it. All right. So now this is going to be a little bit of a fishbowl lens, but I'm not that concerned. I believe it'll be all right for you guys. Let me hop in here and say hello. All right. So now I'm going to hop in here real quick just to say hello to you guys real quick. Let me get over here and mute. All right. I had to mute that real quick. Sorry. Yeah, I can mute that, but I can still play this over here. That'll work. So let's get to work. So we're going to run a couple tests, for the guys that, hop in and check this stuff out. I'm going to be testing some bird meters. And we're gonna go ahead and move it down. It took me a while to get all this stuff set up. It's just a pain in the neck to be able to do all this stuff. It's not easy running tests like this. So it's really boring to video. So I kind of skipped the boring part, got everything lined up, everything's set up, and basically I'm just gonna pretty much just review the things that I've already confirmed. But I mean, it's just something else to work with. I could get into a greater detail of accuracy and a significant amount more time, adding more bird meters in line and testing those together at the same time. But I mean, we're already complex enough on the test. We need to kind of keep, I gotta keep the stuff moving. I can't go too crazy. I went crazy with some of my videos with how deep the level of accuracy I went was. But, we're not going to do that today. So we'll start with our smallest slug. Uh, I think I sold my last 5 watt. I've got 10 watts and a bunch of other ones, but, I think I am, low on some slugs at the moment. Not low on like a lot of them. There's a couple sizes I'm out of. I think I'm out of fives. I sold all my thousands. I might have some more thousands coming in. I sold all my 500s, but I've got 10s, I got 25s, I got 50s, I got hundreds, I got 250s. I've got 10 kW, 25 kW, 2500, 25,000, 50,000, and 100,000 in the bird slugs. But I'm missing 5 watt and a few others. And then I got 1 kW, in this style right here, 10 kW, 10 kW, and 10 kW. So got a couple more 10 kW slugs. So the way I'm going to work this is I'm just going to run this as a test. We're going to start the dead key low. We'll move up like 9 watts or something like that. With just the radio drive. What am I doing? That's facing the wrong way. That's my issue. So we'll move it up, like say 9. We'll drop it back down. It's a little too much. Say 9.5 watts, something like that. So that way we have a reference. This is a 10,000 watt slug, a 10,000 watt slug, and a 10,000 watt slug. So we're going to go ahead and run this down to 10 watt scale. 10 watts on a 10,000 watt slug. That means if I was to have a regular bird slug right here, let's say I had this slug right here. This is a 10,000 watt bird slug right here. There's plus or minus 8% accuracy on peak and plus or minus 5% on, average. If I was plus or minus 5% on a 10,000 watt slug, that puts me at 500 watts of inaccuracy. So on this level, on this scale, I should have 500 watts of, off, in comparison. So about 9.5 here. This is just literally just a hair over 10. This is, under 10, about 9.8. And that right there is dead on 10 right there. So we are, within half a watt of accuracy on the 10 watt scale. So let's go ahead and move up to the next scale. We'll go up to the 30 watt scale right here. And I will change the slug out. We'll move up to a 25 watt slug. Now, there is, of course, some discrepancy between meter movements and things like that. Things do change. But we'll just go ahead and drop our carrier down. and then raise our carrier up. So I'm on a 30-watt scale. Oh yeah, no, I can do that. 25 watts. So I'll line up on the 25. Let's move up just a little bit. Sorry, I'm in a bad spot to really do. Well, I'm not actually. Let me move myself. I had to unkey on accident, but so somewhere in along that. That's 24.8 or so. This reads about 26 watts or so. Sorry, I'm letting go of my key. This reads 26 watts right here. And this reads 25 and a half right there, actually. And this is 26. And this is about 27 watts right there. So there's your next scale up. We'll check our, now, of course, there's some degree of inaccuracy in each slug and each movement. But I mean, we're down within a couple watts. So as long as we're within a couple watts, it's really, really, really close. And they're, like I said, so far it's pretty impressive. Let's just say that much. So we'll go ahead and move up to the next scale. Raise our carrier up. Put it right at the 50-watt mark. Just put it at full scale because that's where the meter should be the most accurate. And then we will key. Now, of course, I can check at a lower scale if I needed to, but this is right at 50 watts. This is about 52. This is about 50 on the money, pretty much. And that's about 51 maybe, or yeah, 50 and a half, really. Just barely 51 right there. So pretty darn accurate as far as that's concerned. Within, like, again, keep in mind, these are 10,000 watt slugs, every single one of these. So inaccuracy should be plus or minus 500 watts. So let's go up to the next scale, 250. I've been preaching these meters for a while. I love these things. Now there is, of course, always something you lose, whenever you're doing stuff. So right now we're dead keying about 125 or so right here. We're dead keying probably I'd say that's 110. Actually, hang on. What is this scale? Let me look. Give me a second. 2, 4, 6, no. Be 5, 10, 15, 20, 25. Yeah. So it is a 5 watts per division. So this is 110. That is 125. And again, like I said, I don't know how perfect my slugs are. Whenever I'm on this scale on a 250-watt slug, I can't dead key any higher, so I don't know for sure. This is plus or minus 5% of 250. So whatever that'd be 12 and a half watts plus or minus. This is 105, and this one right over here is 105. Hey, doing good. Waving a hand, Ninja. Hope you're doing well. Horo, hope you're doing well. And somebody else said WSP, waving a hand. What's this? These are bird meters. If you guys don't know what they are, you guys can feel free to ask. Waving a hand, 1137. Hope you're doing well. I had some YouTube guys hop in and out, want to check out and see what's going on. All right. So, let's go ahead and move on to the next step. So from here, all I have is a larger jump. I wish I had my 1,000 and 5,000 watt slug, but I done sold them. So it's unfortunately part of the deal. So let's go ahead and go. Actually, I'm wrong slug. I could put a peak kit in this, but I don't have the time at the moment. So we're going to go ahead and just go over here and put the peak kit, put it on, this other meter that I've got over here. I've already got it in peak, wasting my battery again. Not paying attention. But we'll go over there. I'm going to change the camera real quick to zoom. Give me just a second. See if I can figure this out. Yeah, that works. Heck yeah. All right. So we'll go over there. There's going to be a bit of parallax there because the angle that you guys are looking at. So you'll have to take a little bit of what I'm saying. Um, uh, more as what I'm saying is, truth than what you're seeing actually. But I hope I've earned enough trust to tell you guys this stuff and you guys can believe me. So it is what it is. If you don't, I can't convince you to. All right. So I've got this slug facing the wrong direction. That was measuring reflect. So currently right now that meter is reading 2 notches up from the lowest division. We're on a 10,000 watt scale. So that means we're going into a dummy load right now. So that means we have 1,000. That'd be, 2000 right there, 22, 20, no, 1200, 14, 16, 18, so on and so forth. So 200 watts per division. So right now, whoops, hang on. My poor slugs over here. They're not liking me. So I just pegged out all my 300 watt slugs because I had it on 300 watts. Now I'm moving it up to 3000. So what is that? I'm reading like 1300 and something watts right now, on that scale right there. So if you were to compare it and actually see right here, these read peak. So here's number one. We'll see what it reads. Of course, there's a bit of parallax error right there, but we're reading, on this scale. What is that per division? Like 1200, something like that, 1120 or something like that. This poor slug needs to go backwards. This one's reading a little over 1,000. That one's reading right at 1,000. And then we'll check it with just a little bit of audio and see if it changes. I doubt we'll have much change. Audio test 1 2 1 2. So the scale on the top end right here is actually tighter on this one, so that each one of them are around 1,000 or so instead of being audio test 1 2 1 2 1 2. So right at 1,000 on that one. Audio test 1 2 1 2 1 2. I really wish I had a 1,000 watt slug to kind of prove it, but the 10,000 watt slug, remember what I said earlier, it's plus or minus 500 watts from full scale. So that means it has the ability to be plus or minus 500 watts, from that, reading. It's most accurate on the highest part of its setting. So the lower on the scale you get, the less accurate it is. That's true with pretty much any slug. So that's just what you have to end up dealing with. But yeah, that's some pretty cool stuff. I'm gonna do one last test real quick. Let's just change this real quick, and let's do tone, fill peak, pull this out. And I've got, this may not be the best slug to do this with. Man, I need another slug. All right, you guys keep buying all my hundreds, so I just sold my last 100. So let's just see what this radio. Audio test 1 2 1 2 1 2 1 2. A little over 100 right there. So now we'll move this scale right here, to test and see what we're doing. Audio test 1 2. Audio. Let me do it tone so it's easier to see. Wrong one. I just clicked something else. So no, not the most accurate test, but whatever. We're doing like 90 on each one of those. The 90 is more accurate than this because I've already done tests like this. But it is what it is. So ideally from full scale, it's accurate on each one. So I'm pretty dang happy with that. It did a pretty dang excellent job. Let me get you out of this camera angle and kill that and then close this booger up right here. It's going to be, if I was to argue anything, actually tighter on the peak scale than what your normal birds are, from what I've seen. Let me go back to 1x. Oh, I can zoom out. There we go. And do back to the full zoom right there. Hey, have a good one. Appreciate you, man. All right. So, that is the bird meters. Just did a test on each one of these. As far as accuracy, if I was to argue anything, I would probably say, this meter is consistently the most accurate, but they're all very, very close to one another. I need more slugs to kind of prove it some more, but it is what it is. You can't really test on a 10,000 watt slug. And then my 250, I already had it was on the high end of the scale before. I haven't really advertised it too much, but I've done a couple videos on it. You can go back and watch the videos and you can see what I said about accuracy on it. It's on the high end of the scale. It kind of a bit of a looser slug. I believe I'd have to reference my own video to make sure, but I'm pretty confident that's the case because I've tested this with that specific radio with a bunch of other meters too. But yeah, very, very happy. It's cool. Like I said, it's really nice to be able to go from 10 watts all the way up to 10,000 watts with just having adjustments here. And it only takes one battery to run. It only checks peak and, carrier. So that's what I was doing. It checks, carrier and average. Of course, just carrier as carrier. but it also checks peak too. So it goes from 10 watts to 10,000 watts all in one slug. This is for a customer. I'm going to get them the best out of these. And then the other ones, of course, are going to be available. I'm going to put probably two of them on my bench just so I have them. I don't know why. More along the lines just for my own sake. I like having them, and I need to set up another row. So I'm going to get them this one. I really need to kind of change a couple pieces. But until then, it is what it is. So this is going to be the one that goes to the customer. I need to tag them in this video, but I have not. He asked me to tag him, but I forgot. It's my fault. So, John, if you check this video out later, I do apologize. I didn't tag you in time. I've been working on this for a little bit, so it just took me forever to get my bench set up. It's not like I was trying to not share it. It's just turned out that way, unfortunately. Hey, we got mail right there. Yeah, that'll work. So this is not the best way to do this as far as each one of the meters is concerned. I would change up the adapters a little bit on this one and this one. But I'm going to do that later because this is not really a priority of this test today. The priority was just getting the meter tested and getting the customer his equipment shipped out. They haven't been that worried about it, but I like to try to promptly get my stuff, and I've had to deal with shipping lately, and because of the weather, it's been awful. It's not enjoyable to have to wait on your products to arrive. So, this booger in line. I will give the customer, like I said, I believe that out of all scales, every set of accuracy, whenever I was testing it earlier, it was the meter that I took out of line is the one that was the most accurate. So that's what I'm giving the customer. I'll keep the other ones and I'll have what I need for my bench. And then I'll get back over here. Back to all is right being in the world. You know, just not how the final layout's going to be, but I'm just putting it up there just so they're out of my way. This one's going to the customer. I'm going to change. What do I need to change? Oh man, I probably need to steal those, pieces off of there because I want to ship it out quickly to them. And I can't do that if I don't have everything I need. Did I do that on video? I will not do it if I don't do it on video. So I'm going to do it. So give me just a second. We're going to do, if anybody doesn't know how to change out a bird meter setup, you're going to know in just a second. So it's not a complicated process. Just have yourself a good flat head and then have a good Phillips head. Depends on the bird meter on which one it'll have. Ooh, I gotta be careful. I didn't think about that. There's nothing in the middle to hold it up. Put that right there. Get down here. So you guys can see what's going on. All I'm doing is this has got the UHF connectors on it. And what? They don't have a UHF? That's got the UHF, does it? Where's my diagram UHF at? Oh, there it is. My bad. So this has got my UHF connectors on it. I'm going to go ahead and show you guys something pretty neat. I like to do this on a lot of my setups, and it's pretty cool to be able to show you guys. Where's that one at? Nope, that's just a bunch of adapters. I organized my bench, guys. It was a nightmare, but I did get it done. There is a mail over here somewhere in this file. Where did I put it? That's not it. So you guys got questions, y'all feel free to ask. If you want to know what these things are, they're bird meters. They're a watt meter to read RF power. There it is. Jeez, man, that booger was hiding. So I actually own two more females. So, and then I got a male right here. So we're going to go ahead and, get the drill to it. So need a flathead. So, hey, waving a hand, Tom, waving a hand, high voltage, waving a hand, Mr. D man. Hope you're doing well. I hope you guys are, having a good, what is it, Tuesday? Let me change this camera real quick. This is cool. I love that. All right. So this is the one I was changing from. This is the one that I had up there. This is the nicer looking one. It doesn't have like little spots on the end of it. So I'm just giving him cream of the crop, not for any other reason other than I just want to. So, well, more than just want to. I kind of, well, yeah, just because I want to. I mean, because all of them were extremely close to being accurate with one another, but that one looks a little bit cleaner than the other ones. And it, like I said, if I had to argue about the most accurate, it seemed to be the most accurate one. So, still that. We'll put this one together first before I do anything else because I will mix stuff up and we'll make sure this customer gets exactly what I'm saying in the video. I think we got too much torque on it. Only bad thing about a drill, this, I flipped these whole bird meters over with loosening these things up with a drill. The drill just like had so much torque, it just flipped it over on its back. So I wasn't expecting it when it happened for sure. One out, one in. Something you can do with these that I like to do is I'll take a nice, just a razor blade knife, whatever, anything. Let me hop back in Facebook and check your guys' comments. Oh, aw, man, that stinks. Well, that sucks. Whatever, it happens. Look, somebody didn't is not going to be able to make it to Hawaii to say hello. All right, so basically all I'm doing is spreading these fingers out, and then when you plug this in, it actually grabs a much better, like nice and tight. So that's something you want to do with all your pins, even though they are a QC and they're designed to be plugged and unplugged. You want to make sure the pins are tight. But the way you tighten the pins is actually kind of counterintuitive. You spread them out. How effective is a dirty balun on the feed point? It is just a choke. That's all it is. So it would do the same thing as what a ferrite would do, but the ferrite has what's called permeability. So there's, something that happens at a choke, and that's definitely RF related for sure. So those are perfectly acceptable questions. 1137. Don't feel like you, have to ask to say stuff like that. Or to feel like it's rude to ask questions like that. It's not at all. I missed a screw. But a dirty balun makes what's called a choke, and a choke, has inductance to it. So every time you put an inductor in line, there's of course things that happen. Whenever you have a ferrite, you have what's called permeability. When you build a normal choke, you do not have that same permeability. You do have heat because there's always something that has to happen whenever you choke RF. So the heat has to go somewhere. So it depends on how much, common mode you have in the system on whether a dirty balun is not okay for your equipment. Because of course ferrites, like I said, they get hot if you put too much RF through them and too much is returning through. So just keep that in mind. Kind of keep in mind how big your center conductor is, how big your, what type of wire you're using, stuff like that. If you're overkill on your stuff, then it's not really that much of a concern. But that would be my only real complaint if you start running, at a higher power level and then you start trying to do a ugly balun. And the thing is, an ugly balun is not really even a balun. All it is a choke. So there's a difference between a choke and a balun. A balun is basically BALUN. So it's changing from a balance, from an unbalanced to a balanced source. So what it's doing is taking an unbalanced feed line and turning it and putting it on a balanced line. So that's kind of the whole situation. It's taken from balanced to unbalanced. Actually, from unbalanced to balanced. So there's a purpose for balancing the currents in your system. That's why a lot of these things exist. And then of course, there's other reasons that you want to use balance too, especially if you want to have like, say, a 4-to-1 balun or something like that. You want to modify the impedance at the source or at the feed point itself. Uh, not the source, but the feed point. Then, you can use a balun there for that too. There's a couple different reasons for balance, but, um, it depends on if you actually want a balun or if you're just trying to stop RF. If you're trying to stop RF, there's a couple different ways to do so. One would be that type of balun, or like that type of choke, just an ugly balun, which is just a choke. A ferrite, a bunch of ferrites in line. And that would just be another type of choke. And then actually doing a true balun where you actually have, a balanced amount of current going from one side to the other side of, the feed point. So basically from the shield to the center conductor, it would be balanced on each side of the element. So a lot of words to explain. There's nothing wrong with an ugly balun as long as all you're looking to do is knock out RF. If you're looking to modify impedance, that's not the type of, balun to use. If you're looking to, uh, if you're looking to do like high powered, RF mitigation, it's also not the one you want to use. So like I said, just depends on what you want to use it for. So I'm just swapping a couple of these out. These are pretty easy to swap out. Like I said, I mentioned it before. I've showed you guys. But it's just 4 screws. Like a lot of guys will say, "Oh yeah, I got a coax inside my shack and this coax or excuse me, I got a meter inside my shack and I really just want to run a PL259 because that's what it has inside my shack or it has that inside my shack and I don't want to hit the change." I can get you literally any size you need. You guys want to put a big old LC connector on there? You can put a big old LC connector on there. You guys want to put a 7/8 EIA on there? I can do a 7/8 EIA on there. You want to hook up a 7/16 DIN connector on there? I can do a 7/16 DIN connector on there. So you're not limited to one specific design or another. So don't get like too scared about this. It's a pretty simple solution. It's not super complicated. So whenever I tell you that it's better for you to get a bigger coax that's got, say, DIN connectors, I'm doing it for your own benefit because it's literally just one connector and a couple screws. It won't take a lot of your time. It won't take a lot of your effort and it will give you a higher power handling, piece of equipment. And of course, you can go to a lower power level on the other side. It doesn't matter. You don't have to upgrade right away. It just gives you that room, that headroom and that, better impedance connector anyway. Um, and you don't have to worry about stuff as much. It's just, I don't know. In my opinion, it's pretty nice. Simple solution. So, ferrites have what's called a permeability. That's one thing that they have. And they also have an effective range. So what a ferrite does specifically is it creates what's called a high impedance path at a specific frequency. So a high impedance path is basically like a big resistor. But if I just grabbed a random resistor and I put it in line, then I would resist the flow of everything. I wouldn't resist the flow of specific things. So if I take a certain amount of metal filings and I arrange them all in one specific direction, rows straight along with each other, I can actually change the frequency at which that actual resistance is seen. And that's what's called impedance. It's frequency dependent resistance. Um, so what you do whenever you do a ferrite is you have a usable operating frequency. So basically a specific frequency that ferrite is able to perform its task or act as a ferrite or act as a resistor in that sense. And that is basically the ferrite's operating range. They have some ferrites that go from, all the way up to like 600 megahertz. They have some that go from 2 to 30 megahertz. They have some that go from, 10 to 50 megahertz. And they have others that go from like 1 to 600 megahertz. Depends on if you want wideband, narrowband, where you want that resistance to be. So when you're looking at RF design on something, it all depends on what the intended result is. If it's RF mitigation, then the last thing you want to do is specifically put, say, an RF choke that has a high impedance path at, say, your fundamental, uh, in directly in line with, say, the center conductor itself, not clipped on the exterior, but say clipped directly on the center conductor. So, uh, let's just say this is my input of my equipment or something like that. Whoops, sorry. This is my input of my equipment or something. And I'm going to clip a ferrite right here. I could put a ferrite with like, say a high impedance path at say 50, megahertz all the way up to 300 megahertz. And what that would do is that would actually take any RF that's at a higher frequency than what I plan on operating. Say if I'm staying in the HF range, and it could actually choke that out. Now you can also do that with something else, and that's what's called an inductor. So you take a core and you wrap wire around an inductor to do that. So, and an inductor by itself, just a wrap of wiring can do that also. So those can be frequency dependent. The issue with a ferrite is it has permeability, and permeability is basically how much power that ferrite can absorb before it no longer acts as a resistor. It turns into basically a straight piece of wire once it goes beyond something called Curie temperature. I just put all three of these up for no reason. This is the one I was wanting to. This is what I get for talking. Sorry. You guys are more than welcome to talk, but it's just me. I need to pay attention. So this is going to the customer right here. All right. And now I'm missing one connector. So, that's the problem whenever you sell a bunch of these things. I should have restocked, probably, I don't know, a couple weeks ago, but, here I am not restocked, and, I am going to use an adapter, basically going on to an N connector back over to a UHF. So simple solution, not a very complicated situation. But it just gives me a connector on this piece right here. So yeah, good question for sure. Waving a hand, smokestack. Hope you're doing well. A ferrite on a power wire. Again, like I said, what it does is it allows you to have a high impedance path for any sort of thing, any sort of RF that's traveling on a wire. So if you clip a ferrite around that, say around this right here, say if I had any RF that traveled off of these coaxes and ran back down the equipment and came back down into, say, the end of a microphone, and then like kind of bit me on the hand or something. What this does is takes any sort of RF that would normally travel back up, and it actually chokes that out at this point and absorbs that. It doesn't send it back down the line; it actually absorbs it. So that's why it gets hot. It takes some of that power and just absorbs it into the system or into the ferrite itself. So the reason that you would do it on a power wire is basically preventing a backflow of RF in a place that you don't want it to go. So if you don't want your coax to go back through your DC line and go back to backfeed into, say, equipment inside the vehicle itself or inside of the environment, say at your shack or at say even in like a laboratory environment or something like that. If RF fed back into the wrong areas, it could cause issues with other pieces of equipment or inaccuracies and things like that. So that's kind of gets into what's called RFI and EMI protection. Uh, every piece of equipment kind of has a certain expectation of it not to affect another piece of equipment. So that's typically why you'll see a lot of equipment that'll have ferrites, like computer power cords. They'll have ferrites on the power supply itself. That is to one, not allow any sort of EMI or RFI from the power supply itself that the computer has to feed into the delicate IC circuits of the computer. So say it had some RF hash or had some, the way you make a power supply, the way you make power with a power supply is kind of confusing for a lot of guys, but I'll kind of explain it real quick. I don't know if you guys will like this or not, but I hope you do, because it takes a bit of effort to tell you guys this stuff. So Uh, I think it's pretty important to understand though. So I'm going to take a little bit of time and show you guys. So if you guys have ever seen a sinusoidal wave, so we're going to go ahead and go for like a top down view right here, and we're going to clean off my fingerprints off of the daggone camera. And there we go down right here. So we'll explain, say, how one of these power supplies work. Just in general, doesn't have to be this power supply specifically, but just in a general sense, you have an AC supply in, you have a DC supply out, and you have multiple components in between to make voltage from here turn into voltage from here. So the way this is achieved in two different types of supplies, you have what's called a linear supply. So you have an input supply rail, positive, negative, or it could be just an AC supply rail. So it doesn't necessarily have to be a positive, negative. It could just be two different supply rails. So you have an input supply right here. And then what you have on like a linear supply is you have basically a transformer right here. And that transformer has a bunch of windings, all sorts of windings. And then it has a bunch of windings on top of those windings, but it's not as many. So the windings on top, generally on like an E-core transformer, is what's called the primary side. It feeds in right here. From here, it's completely isolated right here. There's no connection from one side to the other of the windings. And then the output of those windings goes out to basically an AC out. Say if it's going to be AC in, AC out. There is a way to do it with DC, but you have to convert it to AC, but we'll talk about that in a moment. So you get AC in, AC out. Then you use what's called a full wave bridge, which is just a bunch of diodes that's taking a cutoff, allowing voltage to flow one direction, but not allowing voltage to flow another direction. So it takes like a sine wave like this and starts chopping it, chopping it on the bottom, and then moving it all to the center line. There's a gradient and lots of other things to explain about how that works. And there's filter caps you have to use because of that. But just all in general, it basically chops the sine wave down to where it's essentially basically just a slow rise, slow rise, slow rise, slow rise. And what a filter cap does is just kind of filters the rest of that out to an even line, pretty much. So you'd have a bunch of filter caps right here that would go out of that unit and into the filter caps. And then they would go out the supply rail. When you got a supply like this, a switching supply is significantly smaller. So there's a way they achieve this. They take, your input right here, which is most of the time it's an AC sine wave. Of course, you can do it with DC. Like I said, it's a little bit out of the scope of this conversation, but what they'll use is they'll use MOSFETs, switching devices. So just a bunch of MOSFETs in here. And what they do is they convert, the AC coming in, over to basically a square wave most of the time. So they'll switch it on and then sharply off and then on and then sharply off. So basically, instead of making a sine wave, it makes a bunch of square waves. So the way you do this is you use a bunch of switches, on, off, on, off, on, off, on, off. There's no smooth flow because you're not running it through a winding. You're turning it on and off a bunch of times. So they'll take a signal like this, and they'll have a bunch of switches to switch it on and off. So when you have a bunch of hard edges like this, they have to smooth that out. So you have to put a ton more capacitance right here. And you also have to do a bunch of little bypass caps, these little components right here. It's just smaller capacitors to bypass RF back to ground. So you have to use a lot more filtering and a lot more things to kind of filter that out. So what, happens here is you have a bunch of harmonics because you have a square wave. So when you have a bunch of harmonics on a square wave, it creates multiples. So when we have 60 hertz cycle, and we figure like a second order, a third order, how many ever order harmonic, we go to 120, we go to 240, but we can also hit odd order harmonics, right? So we can hit 180 and a bunch of other numbers. So when we're starting and we have 60 hertz, 120 hertz, 240 hertz, and 180 hertz, and all those have a potential RF hash, a potential amount of noise on it, and that exponentially goes up with every number, that means pretty much the entire frequency is just laden with noise. So if they filter it properly, you don't have to worry about noise. But if they don't filter it properly, that's where ferrites come in. It's a frequency dependent choke. Basically, you're creating a choke to work for a certain frequency range to take all that RF noise floor and filter it to nothing. So done properly with proper bypasses and proper filtering and even some little inline along with the power supply rails, inline ferrites in line with the power inside the unit itself. You don't have to run external ferrites. But depending on who made it, who built it, what type of equipment it is and things like that, there's varying levels of quality control when it comes to what's called EMI and RFI interference. This one just so happens to not make noise, but you can buy another one. I don't have one sitting right in front of me. I think it's over there somewhere, but let's just say you can buy a cheap one, not this Meanwell, but like a megawatt or something like that. And sometimes them boogers will make noise. Uh, but it all depends on what you use. But yeah, that's a long explanation to kind of explain a little bit of what happens and why we have to filter these things. It's generally because of cheaper electronics and the companies not really caring about a small portion of the radio community. So when you operate on an RF frequency, um, you have a lot more potential of interference than you would if you operated like a cell phone. So they're in the gigahertz range. So they're far less likely to be affected by somebody in the megahertz range. So when somebody's up in the gigahertz or 800 megahertz plus up into all the way up to 5 gig plus, those frequencies are so far away that they're far less likely to be affected. But the frequencies in like lower HF, they're orders of magnitude closer. So they're significantly more affected. The problem is if you was to say like out of the entire world, less than 1% of that community is going to have like some form of their own communications where they can talk on the radio, where they have some communications equipment, where they have like a GMRS, HF, um, VHF, UHF, any sort of frequency of any sort of device that can transmit its own power. Or receive its own receive a signal at a specific frequency beyond like just the AM FM. And AM FM, like I said, they're still triple uh, uh, the distance away from any sort of problem than other things are. I'll look at that stuff later. So they basically it's less than 1% of the entire world. Most probably less than a quarter of a percent of the entire world. To be honest, you're not a big enough number to matter. Like the saying where the squeaky wheel gets the grease. Um, we are not a big enough community in the entire radio community, including all forms of communication. Doesn't matter what frequency you operate on. Um, they're not a big enough community to matter. So what it comes down to is a lot of these companies that want to be cheap. Uh, there's a very, very small portion of the community that they're actually going to affect by building their products without proper EMI and RFI protection. Sure, they could affect computers, but they have ferrites. Sure, they could affect other pieces of equipment, but they're unlikely to be affected because they're not receiving on a broad spectrum. They're usually local. So when it comes to just radios in general, they're usually, uh, unfortunately, they don't care about it. Let me move this. So what I'm going to work on today is going to be some 7/8 wire. This has been a long time coming. I had to finish this other one real quick, but we're going to go ahead and get this 7/8 done. So, you guys can feel free to ask more questions. There's other ways to filter that signal, and there's other ways to handle, stuff beyond that. But that's just a half baked explanation. If I really had a lot of times to explain it, it's not really, It's not a. It kind of sounds, if you think about it in a way, it kind of sounds a little bit of conspiracy-ish, but it's not. It's just basic economics. If you think about it, just from a basic standpoint, hey, we can affect 1% of the population, but we can save 30% on production costs. Is the 1% worth the extra 30%? Generally not. So unless you buy usually, and not even always the case, a nicer product that's a higher quality, you typically don't get the EMI and RFI suppression that you're looking for, to not be affected. Um, so ferrites are your friend. They come in handy. They help filter things out that the manufacturer should have filtered out to begin with. And that kind of the goes on the same concept of builders. Builders kind of need to filter those things to begin with, so that other things are not affected as much. If you have a piece of equipment that's affected, typically, the reason this piece of equipment is affected is because it has a manufacturing defect that allows it to be more susceptible to RF. And it's not basically, kind of guys get into the conversation like, um, EMP proof and stuff like that. You get in a scenario like that, or RF hardened. There's a lot of different terminology that these big companies will use. But basically all the terminology is, hey, we're actually going through and trying to actually improve the suppression rather than trying to cheapen out and make it worse. There shouldn't be a term for that. It should be kind of baked into the creation of the devices, because according to the FCC, it's that you have two parts on the rule. It says this device must not, part 15 or whatever, it says this device must not cause any harmful interference to any other device. But the other half to that says this device must accept any harmful interference from any other device. So it's kind of their little scapegoat of getting out of responsibility in general. So your device is not supposed to affect anything, but then again, your device is not supposed to be affected either, because everything else has the same rule. All right. I'll text it to you, Chuck. Just give me a little bit, and let me finish this video, and I'll send you a message. Um, but yeah, I'll send it to you on here. Just give me a little bit. All right. So, I'm going to show you guys kind of how this works. We've got an O-ring seal right here. We have another O-ring seal that goes in here, and we have another O-ring seal right here. So let's zoom in a little bit, turn over like that. I think that's probably a pretty good camera angle. Um, yeah, for sure. I mean, I don't, I hope it helps you guys for sure. Smokestack, hope you're doing well. I saw you earlier. I think I said hello to you. All right, cool. You guys got any other questions? You want to know anything else? If that helped a little bit, I do appreciate it. I'm glad 1137 let me know. Anybody else, if that kind of explained it to you, let me know. If it didn't and you're confused, let me know that too. It doesn't hurt my feelings to kind of help you guys try to understand how this stuff works. There's a lot of nuance. There's a lot of misinformation, and there's a lot of confusion that comes along with like RF interference, how to prevent it, how to eliminate it, and what are the better ways to kind of make it affect you less. Um, there's a lot of misinformation out there when it comes to antenna design, when it comes to antenna setup, when it comes to radio setup, when it comes to station setup, like station grounding. There's all kinds of stuff you got to watch out for. Uh, just don't follow the hype and don't just do what everybody else says. Just try to pair it up with a little bit of research. But even then, I don't know how to explain it in a good way, but there's some, there's a lot of myths that's been put out there for a lot of years, and they're still repeated to this day. What's the family? All right. I'll cut this again in a minute. I just needed to clean it up. I needed to make sure I didn't have any trash or anything to deal with. I've had some guys look at this stuff before. Like, man, he just bent that. I've made quite a few videos on that, but I'll show you guys how to fix that here in just a moment. It's a pretty easy solution. Awesome. Glad you understand better now for sure. That's definitely uh makes me happy to know that I got through somewhat. My YouTube's getting better now. I'm actually able to type in like specific things. And nope, not quite. Not I'm not good enough to be able to just say DWinds RF, but you type in DWinds RF supply, uh, and you'll find me on YouTube without having to do any punctuation or anything else now. So that's pretty great. All right. I'm, popping into the live right there and making sure I said hello to the guys here hanging out on YouTube. All right. I'm not on here for the Twitch guys, so I do apologize for the Twitch fellas. I will get, at some point I'll find a way to really get on there and efficiently say hello to you guys. I don't know. So, um, this is what's called a 7/8 EIA. The next piece that I'm going to be putting on the other side. Let me show you guys real quick so you guys can see it for yourself. This whole thing's going to fall over. It's annoying. Let's do this chair over and hold it up, maybe. Yeah, it worked. All right. I have, uh-oh, where's it at? I got several pieces of equipment in. Oh, it's right here. Forgot I put them down there. Oh, oh no, that's not good. All right. Let me just put that over there out of the way. Ooh, get off my shirt. So the other piece I'm going to be using, let me figure out which one got opened. It's going to be this one. It's going to be not that. Oh, put that back up. Is this right here? This is what's called an LC connector. An LC connector is used commonly in the military, and it has been done for quite some years now. I'll have to figure out if there's more than one in there. We'll figure that out. I got an extra O-ring and I got to make sure it's not getting mixed up. But let's get back over here. So there will be an EIA on one side and there'll be an LC on the other side. So let me show you guys what that EIA is going to go to. So that EIA is going to bolt into this. This is what's called a EIA split feed, something I build and I produce. It's over here. So a split feed looks like this. But basically, it's just the ability to direct feed your antenna connection. This customer asked for a little bit longer leads, so I provided them with that. But yeah, that's how that sets up and how it's going to go. And on the other end, towards their equipment, they're going to have an LC connector. I've also got a custom bracket that I did. I did show you guys before, but just so you guys can kind of see, there's a custom little bracket we're setting up so they can have a good little swivel setup. And then, of course, I built some coax brackets too. I wish I had a way to take a picture of it all mounted and put together on something, but I don't. So, and I don't have that kind of time, unfortunately. So what I'm going to do today is probably going to be go ahead and show you guys the LC. I'll do the EIA later, because I don't have, and I do have it, I guess. I could do that, and then I could do, let's do, what do you guys want? You guys can pick. Would you guys like to see the EIA? Would you guys like to see the LC? So y'all just let me know, and whichever one you guys vote on, we'll pick either one. Ferrite on coaxial antenna. You can put ferrite on your coaxial antenna, high voltage, but there is definitely issues whenever you go to that. There is only so much power that it can handle, and if you go beyond that, what ends up happening is you'll have like I said, the ferrite will no longer act as a ferrite. It will now act as a very, very hot wire. So keep that in mind when you're doing that. And then anybody else? What else? With the EIA, we have one vote for EIA. 104 Indiana. Hope you're doing well, man. Hey, give me them socks, man. Send me a link to them socks, 104. Um, Anybody else got questions? Ferrite on speaker wires, definitely a good thing for for a speaker wires because some speaker wires are more susceptible to RF. So yes, speaker wires are fine. There's nothing wrong with that. Basically, anything you don't want RF in that doesn't have power on it's good. All right, we'll do the EIA. Y'all voted for EIA, and we'll go that way. So LC will be later, and well, I need that actually. It's part of this. So let's get to work. So the way I do this is I have to measure this myself because I am there's not a lot of data on a lot of these things right here. So I have to actually measure it off of here. I did a video a while back and I got hung up. And whenever I was working on it, what had happened was I got stuck right here and I was measuring. I was like, I forgot what it was, 6 mils or whatever. And this is exactly 6 millimeters tall. And I was stuck like this. It was over this edge. Um, so I'll make sure not to do that for this video or else, you guys will be laughing at me pretty soon. All right. So there's two things that I need to do. I need to provide enough space for this piece to slide all the way back. And then I also need to provide enough space for this inner, which one's going to be? Let me line that up. You're not going to be there. You're going to be there. And then you're going to be in here, right around here. So that's going to be stretched out some. It will not be this size, but for this inner ring to sit right here on this edge right inside there. So you can see if you look closely, there's a bevel inside this edge. I'm going to try to zoom, but I don't think it's going to be possible. So please forgive me if I zoom right back out. But this wire is just too hard. I'll be moving it all over the place and it'll be out of the shot like crazy. But yeah, copy. I'm glad I reminded you. Yeah, and I want them heated socks, man. I got cold toes right now. I'll be bragging about it and telling everybody about, Mr. I guess I'll be bragging about your wife, I guess, about Mr. 104's, wife's, Christmas purchase. Hey, if they keep your toes warm, shoot, I'm all game. I don't care. I am a pansy. I'll say it all day long. I'm not one of those guys that wants to be like Mr. He-Man that's got everything going on. And here I am going through like this crazy weather situation and everybody and their brother's like, oh, why are you doing that? It's such and such degrees. No, I'll be having a heated jacket. I'll have a daggum heated set of leggings on. I'll have some thermals on. I'll have some breeches. I want to be comfortable when I'm working. I don't care how much money it costs me to be comfortable. I'm going to be comfortable. There's no point. This is not that one of those ego things where I'm like, oh, look how much I did and whatever. I don't care. I am not that guy. You, I got me a heated scarf, a heated jacket. I got even where's this thing at? Let me show you guys how bad of a pansy if you would consider me. I even got me a heated butt pad right here. So I don't care. If it lets me to work, it allows me to work more efficiently and I don't have to worry about being cold or having problems or anything else going on, or having to worry about my feet getting cold and having to run inside and warm up. Yeah, no, I'm not doing that. I'm just going to do something to keep myself going. Let's measure this with my caliper. Give me a second. I'll pick it up. So the way I'd measure this is going to be a plunge test. So it's not going to be on that piece. It's going to be on this piece. So start with zero, zero that booger out. Booger don't want to be zeroed out, does it? What you moving for? We're not touching that anyway. Go ahead, millimeters. I went the wrong way anyway. Oh, 21 mil. We'll see if this is correct or not here in just a little bit. But I've done quite a few measurements in the past, and I was pretty sure this is where I ended up being. So we'll see. Cross that bridge when we come to it. So now I think I've deburred this, but I'm gonna try this. I don't know if I want to use this one or I want to use the other Milwaukee one. I got a Milwaukee one back here. Give me just 1 second. Pull this thing out. Where'd I put it? There it is. Just a little Milwaukee sharpener. I don't know if it's the right material for the job, if I'm using it right or anything like that. So if you guys say, oh, you should have been cutting it the other way, I ain't got a clue how to do this thing. So all I'm doing is trying to feel sharp enough to me. So I'm just resharpening my favorite, Hawkbill that I've had for a long time. So, oh, here's another thing. I was going to show you guys, and I do it all the time myself. This is what I use right here. I do not use this to cut the wire, but I do use it for something pretty neat. So for anybody that tries to cut the wire with this, don't blame me for your, caved in corrugation, because this is not what I'm doing. I'm not cutting the wire. I'm trying to do something. We'll see if I'm successful in just a moment. Not successful this time for some reason. Probably has something to do with the fact that this is not perfect. Well, it looks pretty dang straight to me. I mean, it's slightly crooked right there, but not that bad. And that's cutting at, oh, it's just my end cut. Let me look. Slightly downward angle. So pull this back straight. Pull this more straight, hopefully. Try this one more time, see if I'm successful. I don't know, guys. If it's not successful, I'm not that concerned about it. But I do. Ugh, no. I mean, I'll be all right with what I got right here, but I'm at least half a millimeter off on one of these measurements. So what I'm gonna have to do is just kind of knock some edge off. It's kind of irritating because I like to have a guide to follow. So I'm gonna kind of go with what I believe is the best. It's not critical at all. Well, hang on. Nope, nope, nope. We gotta zoom out. Here I am. I bet you I wasn't in the shot for that whole time. So sorry about that if I wasn't. That's what I get for zooming in. I told you guys that I would do that because you'll see me jerk my head around and I'll be looking around and trying to see the whole connection, trying to cut it straight, get everything lined up. It's just not really a user friendly operation for kind of making this uh, where you can watch every little piece of it. I do my best to let you guys see this stuff, but, there's some stuff it's just too hard to show. Like if you guys have ever seen me do 1 5/8, I'm always zoomed out. And it's not because I'm trying not to show you guys. It's mainly because it's just too much daggum work moving around that daggum big old wire. So it looks like we're pretty good all the way around. I have no complaints with that design. So now we got to see if I cut it right. If I cut it wrong, what's going to happen is I'll have an issue, and I'll need to, of course, cut it further down. So the way I work this out, we don't need a belly in the shot. Go up here, over there, a little bit better. If it goes out of the shot, then we'll go from there. Whoa. Doo-doo-doo. All this is just making sure this thing don't get crazy scratched up or anything whenever I'm putting this on here. Let's see if this is far enough. If it's not, I'll have to cut it down further. I have a feeling that it's not going to be far enough. I think I'm going to need to go to the next rung. I may have missed something in my measurement, but we'll know in just a moment. So what I like to use on this is my needle nose, and they're right here. I'll go inside this connection and I'll just round that out just ever so slightly. They don't have to be perfectly straight yet. We will work on that shortly. We're just trying to make it as cylindrical as possible so I can slide this on without issue over top. So the main complaint of the way this sets up when I'm doing this is going to be, oh, that's not going to work. Sorry, I'm gonna have to do like a top down view or something so you guys can see what happens when I'm doing this at the same angle as me, maybe. So if you look, I don't want to use these. These are like $100 pair of needle nose, so I don't need to be wasting my needle nose on something like that. So I'm just gonna run this thing out. Good night, little ones. Blue, the Z24 finals in my Anytone Q6. So trying to find a place to get it rebuilt since the original Q6 did continue to do this. Give me a shout, on here and I'll message you later, Todd. I don't really talk about the other, setup, on here. This is an RF supply. So this is not my other business. So, if you want to message me, feel free to message me and we can go from there and I'll let you know. I said it. Good night, little ones. Hope you guys have a good evening. All right. So all I'm trying to do is go past this little edge right here. It's not. Let's see if anything else is stopping me. So this is fine, but I do need to bend this in just a little bit. If I can grab this piece. There's a little bit of an edge right inside here. There we go. So I need this to seat. Now, if it doesn't seat, I may have the O-ring blocking me. So the way I would know that is I scooted this all the way up. I'll do this with a rag. See if I can get it to slide. I'm fairly confident it's the one stopping me. So if this is scooted up to here and I'm like that, and this is lined up in this position right there. Yes, makes all the sense in the world. So this has to have a little bit of motion to slide. So I don't believe I'm going to be able to go by with that tight of a tolerance. So that's why they do this. They have such of a rung. If I can make it happen in a, what do you call it? A nicer method, then I'll do the best I can to do so. But I mean, there's only so much you can do. So we'll just cut it down. I've got enough tolerance in this to go to the next rung, but I wanted to be a little extra, I guess. Anytime I can try to improve upon a design, not really in a perspective that's going to cause it to change the way it functions from an RF perspective. but mainly change the way it's sealed and how tight of a tolerance it has. I try to do so. Like manufacturers, they want to have a connector that's the easiest to put together. They do not want to have a connector that's very difficult for somebody to put on because then it's really hard to sell. So a lot of times they'll leave a lot of room in their design that allows you to make mistakes and allows you to go um, further than what like you would have to go. So I try to, if I can help it, eliminate some of that extra tolerance if possible. But see, I'm well within, I'm underneath all my connections. Everything's fine, but it's just kind of frustrating to me because I like to have stuff really nice and tight. You guys can see all this, right? Yeah, we're good. Cletus waving a hand. Hope you're doing well, man. You missed the bird stuff. I did some bird meters earlier. It was fun. I guess fun for me, maybe. I don't know. I like testing up some of that bird stuff. It's a bit time consuming, but it's not too bad. So I'm just going around this corrugation and squeezing it in just ever so slightly and getting all these things nice and set inside their positions so that I can slide this up all the way up to there. And there we go. So now we're seated around the upper ring. This connector is put in the position that it needs to be put in. And then from that point, I'm going to go ahead and set my flare. So what I like to equate this to is like the flare that you put on like a copper pipe or something like that for your gas fittings. You're flaring it like that. You want a big flared fitting at the end. You also do want to be careful because if you hit it with the palm of your hand, it'll cut you. So just go slow. Don't be in a big rush. Don't put a ton of pressure because that's how you get cut. Just because it's not like one straight edge of copper that's got a sharp point on it doesn't mean it's not going to cut you, especially if you're going at an angle like I am right now. I've cut myself a few times, not like majorly by any means, but enough to be wary the next time. You guys got questions, y'all feel free to ask. If you'd like to know anything about what I'm working on, I'm working on some 7.8 TIA, on some 7.8 Heliax. If you'd like to know about my other 7.8 hardline that I have to offer, then you know, feel free to ask about that. If y'all want to know about bird meters, if you want to know about Hawaii coming up, whatever y'all want to know about, y'all feel free to ask. Otherwise, I'm gonna keep working on this connector, and we'll talk about it. So I've already got my flare out now. So all I'm doing is flattening my flange out where it's even all the way around. And I'm doing a little bit more than just a flare. I'm actually beveling over top somewhat everywhere that I can. If it catches and doesn't work, I just take a little pair of dikes and just chop it off the end. But I try to make it extremely hard if I can help it for my connectors to come off. Center conductor right there. We'll run this test real quick. I tried this last time and I was not successful. fairly confident. I'm gonna leave it alone. We're not doing that. So we're gonna do this right here. So I had to cut this last time. I had to grind it down. So if you look right here, there is a degree of thermal expansion on Teflon that I had to deal with before. So right now it's sitting in there nice and fine with no problems whatsoever. But now let's go ahead and do what we were doing before, what I did last time, and I'll show you guys. Just get my vise over here. It's kind of a weird angle to pick this thing up. Hopefully I don't hurt myself. Let's see how this goes. Dang, man, this thing's heavy. It's not that heavy, but it's just awkward to grab from such a far angle. That ain't gonna happen. Ain't no way. It ain't that, but it's just weird and awkward. I'm trying not to flip in my chair, grabbing it from that far away. Oof. Back we go. I think I've had this vise between this location and somewhere else for, good Lord, probably 20 years. I don't know where it came from. It's somewhere cheap. It wasn't that expensive to begin with. So I need some solder. That's going to be over here. Well, let's go ahead and start adding some. So the way I'm going to do this is I'm going to try. I had to do it with I need a sponge. So you guys can't see me wetting the sponge off screen. It's not like it's super special or anything. It's just literally wetting the sponge. So, and you'd be surprised how much these daggone sponges hold. A lot of daggone water. So, clean off the tip of my soldering iron. I don't want it to look ugly. I don't really care too much about like just a little bit of hairs and bull crap like that. Something like that's fine. There's a little bit of sponge material in there. Just whop it a few times. See if it knocks it off. Nah, there's a little bit over there. Scrape it. Yeah, it's actually a pretty good spot. So now she looks fairly clean. So let's start working. These closed captions are flat, closed, whatever. Captions are getting pretty good. Because I'm looking at my, Facebook and it's got it muted and it's popping up little captions on there and it's working pretty good. But that's got to move. What if I need to get over here? Let's see if I can get the right angle on this piece. Get my leg out of here. And then I doubt I'm going to be able to do this. This is a little bit too much to ask for. Throwing this booger up on my shoulder. You guys can kind of see it a little bit in that, reflection over there. That's too far away. Don't follow me. This is weird. All right. But I'm going to try it anyway. Because it's the best angle to do this. So zoom you guys in nice and close. Uh-oh. Whoa. I've done this like 3 different lives in a row almost. All right. Sorry about that, Facebook and YouTube. I was at 1% battery life. So that was that might have turned out bad if I didn't watch it. I just killed my gimbal. Get back over there. So hopefully this thing stays alive. I do apologize if it dies. It's not really my intention. Get out of there. A little bit further down. Thank you. No, wrong way. That way. All right, gimbal's being a little bit temperamental. When you plug a power cord into the gimbal, it senses that extra like tension on it, and it does not like it. So I say a power cord, it's a USB cord. But we're working on some 7/8s. What I'm doing is I'm going a step beyond. According to this manufacturer, they really don't care how you connect it or solder it. But me personally, I do have a bit of a care on how I solder it. So what I do is, rather than just a mechanical connection, I'm going for an electrical connection also. Of course, a mechanical connection can be electrical, but it's not as effective at frequency. So my goal here is one, not to get sliced in the neck by this daggone zip tie, and two, to add enough solder on here for this connection to bond. So I don't really care uh, how well the solder spreads out specifically, not in like any real deep sense. I just want enough solder on that edge that when I throw some heat to it, it'll be able to use it and suck in and bond. It's not where the majority of my solder is going to be, but I will have some right there. All right, so now, hey, have a good night, man. See you 11:37. Hope you have a good one. So from here, yeah, I didn't mean to start the live as late as I did, but those bird meters took a while to set up. I cleaned up my whole bench, and then I had to make it dirty again. And luckily enough, I was able to clean it up again while I was on the live. So worked out pretty well for me. Got to have a pair of pliers so I don't burn my hand. I can grab it by the Teflon, but not going to be the case very soon. We'll get my torch down here. Oh, uh-oh. I'm losing a little bit of heat, but it's not the end of the world. Cool thing about a torch. Uh, there you go. Get back in there. Gotta make sure this hasn't expanded too much and also make sure this stays centered. So I have to kind of line this up pretty quickly. So give me a second and this might not be able to be on footage. I don't know if I'm zoomed in too far or not, but apologies for the guys that I don't get to see this. Well, you guys can see it. Cool. We're good. We're good. We're good. Yeah. Woohoo. I beat expansion. So I was able to put it on in a way that didn't, cause too much expansion. I've done it last live that I did the 7/8 with. Uh, I caused too much expansion and I had to actually, modify and cut down the insulator on the, bullet. So I've got some tools for this. Hopefully this will get wide enough. It will not. We'll see if I got some other ones. This one will absolutely get wide enough. So we've got a solution there. So, and then I've got another one right here. Maybe this will get wide enough. It will not. And I've got another one down here. Let's see if this one gets wide enough. It also will not. Then I got another one right here, and I know it'll get wide enough. So that was a few too many to go through, but it's good enough. Let me turn the video over here so you guys can see what's going on. Let's lock this booger into place and start tightening her up. So you want to hold, it really doesn't matter with this type of connector actually, but you want to hold the rear of it still, the bottom, the base, while tightening the front. So the last step's a bit counterintuitive, kind of worries everybody, gets them scared, but do absolute best to try to pull it off. If you can pull it off, it's not on there tight enough to begin with. You need to redo it. So don't get super distraught if it pops off. That means it would have popped off at some other point in time. Don't try to wiggle it off and rip it off, but try to pull it laterally off. And if you can, then I think laterally would be behind you actually. Uh, basically just in a straight motion. I wonder if lateral is the correct term. Uh, but just try to pull it straight up. Try to get it off. If you can get it off, it's not on there good enough to begin with. So, I like this. I like this. Oh, I've got a different torch for this. Look, what? See how the flame is like this? I grabbed a different torch just so I could do this. It's way over there. Jeez. Oh, Lord. Okay. I was way down there. Okay. So this one, see how the flame's much wider? I like to use it for stuff like this just because it heats pretty even. All right. Bigger torch, wider flame, spreads it out even more. I like a heat gun. Heat gun's all right, but it just doesn't give you enough heat fast enough, in my opinion. That's my main complaint with a heat gun. So, da-da-da. Bullet lines up, centers on. There you go. So let's zoom out just for a second. Let's turn this camera this way. Maybe it won't jack up everything. I don't know. Maybe. All right. Go that way. And I'll kind of show you guys how this is going to work because it's pretty neat to be able to see it anyway. Something I'll need to do regardless. This, how many of these will I need? So I need right there. And then I need this right here. So we'll put you guys at a better angle than this. Maybe this will work. Up you go. Something like that. And you guys will see how this works. So let's say we had a connection or something like that, and we had to make a very tight bend or something. In this case, this customer does need to make a bend. So what I would do is I would be able to make that tight bend. So let's say this is where I'm coming up from, because this is what's actually going to happen in this application. I'm going to be coming up from this position right here. So it's going to be like this. Rotate here. Let's put my O-ring on. Where's my, I knocked it in the floor, didn't I? If I did, I don't know where it's at, but I've got a bunch more. So just grab another one. Draw her. Get it back here. I'm sorry, YouTube. I haven't been responding to you guys. If you guys got questions, y'all feel free to ask. It doesn't hurt my feelings at all. So feel free to ask any questions you like. I've been paying attention to Facebook a little bit more. So not that I'm intending to neglect you guys. It's just kind of happening that way. I'm just working on this wire though. So, all right. So now we have to get a couple tools and a couple pieces. So I'll need this right here. I've got those three right there. I already had that. I've got these three right here. So this is going to be mostly how this is set up for a final build anyway. So I'm just doing this to finish this up. I'm going to hand tighten all these for reference sake. So see how it's set up right here? So it's set up like this. And then this point right here will be here. Let me grab a couple more components so you can show you guys how this will line up. Oh. So there will be a bracket right here. And this flange will sit right inside this bracket right here. This whole piece of coax is going to be loaded to the ground, something like that. So it's going to come up to this bracket right there. Then I'm going to have another bracket like this down here. It will be clamped onto the wire like this right here. So let me turn it down to an angle so you guys can see kind of what's happening. So it'll be clamped onto the wire like that. So you see how that works? There'll be a clamp here holding this in place, and there'll be a clamp up here holding this piece in line. So go back over here so you guys can see what's going on. So I've got some special hardware to go through for this, and then the split feed will attach right here. So that's how this whole setup will look for this customer. I guess I can show you guys maybe a little bit. Still on the shot? It is, looks like. Might as well. Oh, I'm not sure if I modified this yet. So whenever you do these, dang man, I'm not twisting because I wasn't holding it. All right. So let's see how this clamps right here. Runs through, clamps onto that right there. So I'm going to modify this slightly. This is going to be, luckily you guys don't have to smell this. That's annoying to have that much on there. So now we got a sacrificial rag that I'm not concerned about. On there, I don't want it on my sponge. So all I'm doing is just lowering this connection. It wasn't clamping exactly the way I wanted to clamp. So let's see if I can get away with flattening this clamp out the rest of it. Yeah, very, very, very close. So it's good. Happy with that. I'm going to clamp through right here so I can show you guys how this works. It's good for a proof of concept anyway, so you guys can understand how it sets up. I don't have a mock-up boom, so you guys will just have to imagine one being there. So imagine, if you will, a boom like being this 2x4 right here. So in that position, it'll be U-bolt, U-bolt right here, and then U-bolt, U-bolt right here. So that's how this thing is going to set up. And then of course this is going to be hard mounted. It's not going to be flexing or moving or doing any of that stuff, but this is how this is set up. So it goes from feed point, goes straight down from there. So that's a pretty cool setup. I'm pretty happy with how that turned out. Looks pretty good. And I'm also going to send this to the customers so they can have a mock-up of how I expect the design to work out for them. So they can use that for a reference if they need to. They may well have it all figured out already. It's not really my job to like they can set up however they want. They got their own choices, but this is just how I envision setting it up myself if it was my own. They're buying the equipment, they're putting it together how they like, so that's up to them. I am just giving them an idea. Now, I typically don't set up my clamps to run in this specific fashion, but this is a very unique application for this customer, and it works for what they need. There, there. This is going to stay there. They also got some other pieces of equipment from me, which is this high voltage wire right here. And then, of course, I've got all the bullets I need right here already. So, one Douglas in here. One more to go. You guys got questions? Y'all feel free to ask. Like I said, don't hurt my feelings to answer them. Not trying to be secretive or nothing. So if I put this right there, that's why I need it. So to here. So we're just lining up the rest of this so it's done. The customer will have everything mounted and put together the way they need it to be. This is pretty easy to pack like this. I don't think it'll be very difficult. I hope, at least. If it is difficult, we'll be removing this and taking it back apart. We'll cross that bridge when we come to it. Hopefully you guys are not dead over there. We're good. We still got power. Got some juice to the camera. But yeah, that's a pretty cool design. I think it's pretty neat. If you guys have any more questions about it, feel free to ask. If y'all want to ask me anything else before we call it night, let me know. I've got to do a little. Well, I'm not sure how much more I got to get done tonight, but I think I'm pretty well finished for the evening. Get out of there. I'll be doing a little bit of this for a minute, but I'm trying to think if I need to do anything else specifically. I've got another 1/2 inch harness coming up, and then I will be caught up. If anybody wants anything before February 7th, you're going to have to order, like, if you order something like a bird meter or something like that, I can